Hello and welcome back to Pharma E-Class. I am Anindya Goswami from Smriti College of Pharmaceutical Education, and we were discussing different types of mixers. So in the previous classes we have discussed about the mixing of solids, and for the purpose of mixing of solids we have discussed different types of mixers and blenders. Like for example, planetary mixer, sigma blender, double cone blender, V cone blender, zigzag or continuous type of blenders. So mixing of solids is particularly quite an important job because maximum of the drug particles comes in the solid forms. Next we studied with the mixing of liquids, different types of liquids, maybe miscible liquids and may also be immiscible liquid, that is liquids having difference in densities and properties. So now we'll move on to the mixing of semi-solids. So while mixing semi-solid dosage forms like ointments, creams, pastes, jellies, they must be brought to the agitator, or to the agitator must move the ingredients throughout the mixer. Because of the semi-solid nature of the particles of the ingredients, so the agitator must move throughout the mixing tank, or all the particles or the ingredients must be moved nearer to the agitator for the complete mixing to be done successfully. The mixing action includes a combination of low speed shear, smearing, wiping, folding, stretching as well as compression. Because a number of ingredients are being used and maximum ingredients are sometimes in, like the ointment bases, they are in semi-solid forms and all the powdered ingredients are in solid forms. So mixing of the semi-solid ingredients with the solid ingredients ultimately to form a semi-solid dosage form, it includes a variety type of combinations of the action of the speeds, that is low speed shear, smearing, wiping. So mixing is brought about by these actions like low speed shear, or the mixing at a low force, generation of low force, then smearing, wiping, folding as well as stretching as well as compression, because we have to disperse all the ingredients inside maybe an ointment base or a cream base. So this type of this combination, these are the actions which combines to the formation or the generation of the semi-solid forms of dosage. High force is required when effective mixing and power consumption is also high. The speed must be changed according to the nature of the particles or the material, that is if the materials are thixotropic or the materials are viscous or the materials are plastic or pseudoplastic, that depends on the properties of the material, either they are thixotropic or they are having what particular behavior. So we have to improve or decrease, we have to increase or decrease the speed of the mixing so that it gets accordingly with the nature of the ingredients. So let us come to the classification for mixers of semi-solids. Maximum mixtures we have already studied, or blenders we have already studied, which are also routinely used for solid mixing. Like for example, we have agitator mixers, that is for example sigma blenders or planetary mixers. We have already studied sigma blenders. If you have recalled, in solid forms of dosage we have studied sigma blender, which is a static type of mixer in which it is provided with sigma or S-shaped blades, and lump formation of solid particles as well as maybe of semi-solid ones also. The lumps are broken down by the moving rotatory sigma blades or S-shaped blades. So it is categorized under the agitator mixer. Next we have planetary mixer, which is another sophisticated machine in which inside the static trough there is the rotating blades, and the blade, that projection blade can move anywhere in the rotating trough. So there is a minimum chances of formation of dead spots. Next we also could classify as shear mixers, where generation of force or shear is occurring, like for example colloid mill, which we have already studied in the mixing of immiscible liquids or the preparation of suspensions also, where the mixing efficiency is done by the moving rotor and the fixed stator. The particles to be mixed, the oil globules or the suspension materials to be mixed is put into a force or shear between the stator and the rotor, and that's why the decrease in the particle size or the miscibility or the dispersion of the proper oil globules happens. So colloid wheel also we had studied, quite an important machine. Next, another important machine which is being used for mixing of semi-solid is a triple roller mill, that we'll study today. Next, what are the selection criteria for semi-solid mixer? How do we select which type of mixer or which category of mixer we need for our particular production of our semi-solid? That is again the physical property of the material, the density, the thixotropy, the viscosity, as well as the miscibility of the ingredients. Which category of ingredients we are working with, and what is their density and what is their characteristics or their physical properties, that is very, very important. Next, the economic consideration, that is the time required and the power consumption, because the mixer they'll employ a great amount of power, and we cannot go on mixing for a single batch the entire day, so the time required as well as the consumed power. Next, the equipment cost and maintenance. We need a good equipment, a proper equipment with low maintenance and a low cost, so that is also an important factor. So these are the selection criteria for semi-solid mixers. So this is a important equipment used for mixing of semi-solid, that is triple roller mill. It is evident from the diagram. This is the outline and this is again the proper diagram like that. Yes, triple roller mill is an important machine where we can mix different types of semi-solid like pastes, ointments and creams in particular. So there are 3 rollers, that's why the name, that is triple roller. And what is the principle? The principle is high shear or high force, which causes crushing of aggregates, particles, and also distributes the drug uniformly throughout the semi-solid base. Because maximum of the semi-solid, they employ a base like ointment bases of varied nature. So we have to disperse all the solid ingredients properly inside those semi-solid bases. So high amount of shear is required, which causes the crushing or breaking of all the aggregates or the particles, and they distribute the drug uniformly throughout the semi-solid bases. Now come to its construction. It consists of 3 parallel rollers of equal diameter, and in the maximum cases they are made up of stainless steel. These are mounted on a rigid frame, and which the frame is placed, and the frame works horizontally. Next, the gap between the first 2 rollers is more than the gap between the gap between the last 2 rollers. So the gap between the first 2 rollers is quite more in compared to the gap between the second last and the last roller. Why it is such? Let's come to that. A hopper is placed in between the first 2 rollers. This is the hopper which is placed. That is, if this is the roller, this is the first roller, this is the second roller, and this is the third roller. So material feed will happen from this. So this is the first roller, this is the second one, and this is the third one. So see, this is the hopper, all through which continuously the material feed is being inserted. So the hopper is placed in between the first 2 rollers. A scraper knife or a scraper blade, which is blunt in nature, not quite sharp. A scraper is attached to the last roller. Yes, this is the scraper. This is the knife edge for the removal of the material. A scraper is attached to the last roller. The first roller rotates at a lower speed compared to the second, and similarly the second roller's speed is less than the third roller. So this is the beauty of this machine. That is, the first roller, it rotates at a low speed, the second one rotates at a medium speed, and the third one rotates at a high speed. So when materials are coming to this, so if the roller is rotating like this, so it will pick up all the feed, because it is a sticky materials, the semi-solid materials, because we have to dissipate or disperse all with the solid materials with the ointment bases. So it will pick up the material and it will put it here. Then also this is rotating, and subsequently a layer of this particles and the ointment base will be placed on the roller, and subsequently when it reaches to the third roller, it has been mixed, and at a high speed this is happening. So a layer of this ointment or a cream or a paste will come on this third roller, and which is been obtained as we scrape it out with the help of a scraper knife. But remember, the scraper knife must not be sharp. The scraper knife is a blunt device. Only it is used to eliminate or to move all the particles or the ointment bases or the ointment proper, which is our product. So we can remove the product from this with the help of this scraper knife. So quite an important machine and routinely used in ointment and semi-solid industries. Come to the advantages. From small scale to large scale or to large batches we can do. The roller mill, the 3 roller mills are ideally available or ideally suited for handling of small to large quantities of semi-solids. And excellent temperature control is also enabled. It is provided with good temperature control of the products as the product is processed as thin film on the rollers. Because the hopper is placed between the first and the second roller, so on above the second and the third roller the product is being processed as a film. So it can be cooled or heated depend upon the requirement. So each and every roller can be provided with such attachment that the material, if it is needed for cooling, then cooling can happen. If the material is needed for heating, then also that attachment can be done. Next, extremely uniform distribution. This machine provides quite good uniform distribution, low material cost, minimum contamination if it is placed on a covered system, so minimum contamination will happen. Plus the rollers are made up of stainless steel, so stainless steel is also proven from is a rust proof device, so contamination the chances is quite minimum, as well as easy cleaning. So when we have to stop the batches, we have to stop all the operations, and we can clean it quite easily. So we are into the last topic of our mixing chapter, that is mixing index or mixing indices. So what is basically mixing indices? It is a statistical derivation of your entire mixing process. So when we are going on mixing solids or semi-solids or liquid or whatever is our content, so after our particular the process is over, time to time we have to assess, the quality control and the quality assurance department time to time assesses whether the mixing has been occurring properly. So for that purpose we sample out things. Sometimes we do mathematically, sometimes we do also random sampling. And afterwards, from those random sample blend which is still going on, and also from the unmixed powder blend, we statistically evaluate, we statistically calculate what is the mixing indices. So mixing indices involves the comparison of standard deviation of sample of a mixer under study with the estimated standard deviation of a completely random mixer. So it involves, that is, it can be expressed in two ways, that is M, where M is the mixing index, it is sigma R divided by sigma, or M is equal to also given as sigma 0 minus sigma divided by sigma 0 minus sigma R, where M stands for mixing indices. This sigma R stands for the standard deviation of the random blend, that is the samples which we are taking randomly, so it is the standard deviation of the random blend. Next, sigma, the standard deviation of the sample blend, the sample which is to be blended previously when the mixing process has not started, so this is of the sample blend, and this sigma O is the standard deviation of the unmixed powder. So in a simple way, mixing indices must be calculated to constantly keep a vigilance on the mixing process, because if we go on mixing without any checking of the mixing indices whether your machine is working properly or not, so after some time we can see when the mixing process is entirely over and the machine has run for a certain period of time, so this has gone to a particular time and wastage of power and cost has happened. So still mixing indices should be calculated, and then only after we see there the mixing indices values are proper, then only we can check into the consideration the mixing index has happened. Thank you.